called symmetry. S-Y-M-M-E-T-R-Y. Big fancy word. The human body is symmetrical. If you take a mirror and you put it up to your face, you ever try this before? The left side of your body should match the right side of your body there, yeah? In terms of symmetry, you should have balance there. If it took the ball, how many seconds to get to the peak? It went up, let's see, right? 1, 2, 3 seconds to the peak. How much to come back down? 3 seconds. So if you take off and return to the same level, the time up is symmetrical to the time down. You see that? So how does this help you? Here's a little trick. On problems that involve going up and down, it's too much work to solve for the whole thing. Too many unknowns. You guys look tired. Let's just do half the work. So one little trick is just solve for going up or solve for coming down. And the reason why that's really nice is if you solve for just going up, then at the very peak, what can you set the final velocity equal to? You can set it equal to what? 0. That's an awesome trick because in 3 out of the 4 nifty equations, VF will just drop out because you set to 0. Is that nice? How about if you want to solve for coming down? That's also nice because here, what can you call the initial velocity if you're solving for coming down? A big fat what? 0, exactly. So use symmetry. Here's another symmetrical pattern we can notice. What do you notice about the speeds on the way up? 30, 20, 10, 0, negative 10, negative 20, negative 30. The speeds on the way up are also what? Symmetrical to the speeds on the way down. Notice I'm saying speed, not velocity, because on the way up, it's a positive velocity. On the way down, it's a negative velocity. But the speeds are symmetrical. So that's just kind of a nice intuitive fact to know. So if you throw a ball up at 30 meters per second, how fast will it be going when it comes back to your hands? 30 meters per second. So practically speaking, it's just a symmetrical thing about gravity to appreciate. It's the same gravitational field that slows a projectile down on the way up as it is that speeds it up on the way down. Finally, the last thing we can see is it's not really the distances so much, but the displacements, you can think of it that way, on the way up are symmetrical to the displacements on the way down. It's not equal, but they're symmetrical about the peak. Notice that it's 25, 40, 45, 40, 25, 0. You see that? There's symmetry there. We can apply that to make our life easier.